Hello students, good evening. So now I am uploading the long videos of advanced subjects electrical machines for your benefit, which will be the syllabus of BE first year or second year, and even for the computer courses also electrical machines will be used. Even in the GATE and RRB etc. you will be having the benefit. Please listen carefully. Electrical machines are of two types. One is DC machines, another one is AC machines. AC machines. Under DC machines, the machines which are operated on the direct current, they are called as the DC machines, and the machines which are operated on the alternating current, they will be called as the AC machines. Now, under the topic of DC machines, DC generators, DC motors, and electronic devices, etc., they will be operating on DC. Electronic devices also you can consider which are operating on the DC. What are the AC machine, AC generator and AC motors? The broad classification of the AC motors are induction motor and synchronous motor, maybe single phase or two phase, three phase you will be having depending upon the type of the construction and type of the use they will be. So now, first of all, you should understand what is the generator, what is the motor in electric machines and what principle they will be working. DC generator means a machine which converts the mechanical energy into direct form of electrical energy, that will be called as the DC generator. And what about the DC motor? DC motor is a machine which converts the direct form of electrical energy into mechanical energy, that is called as the DC motor. Whereas AC motors are concerned, a machine which converts mechanical energy into direct alternative form of electrical energy will be called as the AC generators, and a machine which converts the that is what alternative form of current energy into mechanical energy, that will be called as the AC motors. So once again, induction motor and synchronous motor. Induction motors are variable speed motor, they work on the principle of electromagnetic induction. Even synchronous motors are also working on the principle of electromagnetic induction, but they rotate at the constant prescribed speed. Their speed, of course, all of a sudden will not be changing, and they will be very costly in manufacturing and operating also. That's why they will be rarely used in the industries, whereas the induction motor will be used commonly in the industry, and they will be manufactured from fractional HP to thousands HP, whereas there are the standard of synchronous motor. Anyhow, in detail we will be discussing later when their terms come. As I told you, both the machines, whether DC machine or AC machine, will be working on the principle of electromagnetic induction. What is the electromagnetic induction? Electromagnetic induction is whenever conductor cuts the magnetic field, an EMF will be inducing the conductor. According to Faraday's laws of electromagnetic induction, whenever conductor is rotating in the magnetic field, an EMF will be inducing in the conductor or the coil, or otherwise whenever the magnetic field is linking with the conductor, in that case also the voltage will be inducing in the conductor. This is determined by Michael Faraday and divided into two laws that will be discussed in detail as a chapter only. But here, by taking into consideration the electromagnetic induction, there are two types of electromagnetic induced EMF. One is dynamically induced EMF. The other one is statically induced EMF. Statically induced EMF. Dynamically induced EMF is one in which either the magnetic field is kept constant, conductor will be moving in the magnetic field, or otherwise magnetic field is kept constant, conductor will be rotating in the magnetic field. It means one is stationary, another will be rotating. That is the basic law implies. Whereas in case of the statically induced EMF, coil is always stationary and magnetic field be linking with the stationary coil. There are two types of statically induced EMF. One is self-induced EMF. The other one is mutually induced EMF. The example of the self-induced EMF is the chalk, buzzer, LED bell, etc. Chalk of the tube light, you can take the example, whereas the mutually induced EMF example is transformer, where the voltage will be shared in one coil, the other coil will be inducing the EMF. Two coils will be used wherever the voltage inducing in such logic, that will be called as the mutually induced EMF. The dynamically induced EMF is concerned, that will be anyhow explained in detail in its own chapter, but time being, why? Because it works, the electrical machines will be working, that two DC machine, other AC machine, they will be working on the principle of dynamically induced EMF. Finally, Fleming's right hand rule and Fleming's left hand rule that I am trying to explain you people. So, the dynamically induced EMF will be given by BLV sin theta, where B is the flux density in Weber per meter square, or its actual unit is Tesla. Why? Because the scientist Tesla has determined the magnetic flux density, that's why it is named after him only. While L is the length of the conductor which is rotating in the magnetic field is taken in meter. V is the velocity or the speed of the conductor at what rate it is rotating in the magnetic field. Theta is the angle between the conductor and magnetic field. So, this is the induced EMF dynamically in the DC generator or AC generator. Their individual equation depending upon the number of parameters will be discussed. One DC generator and AC generator, they will be coming. It is a broad class. Now the standard classes will be discussed now, started. Elementary one side will be running and the standard classes will be other side will be running. Where the electrical machines are concerned, you please open and listen carefully. So now dynamically induced EMF, wherever it is inducing in the DC machines or DC utilization, that will be given in the Fleming's right hand rule. In case of the Fleming's right hand rule, hold the thumb, forefinger and middle finger of the right hand mutually perpendicular to each other. The meaning is thumb is perpendicular to forefinger is perpendicular to middle finger, and middle finger is perpendicular to forefinger. Now you see, If the generator is rotating like this, the thumb will be representing the direction of the rotation of conductor, forefinger associate the direction of the magnetic field, and middle finger indicates the direction of the induced EMF in case of the DC generator. On the other hand, Fleming's left hand rule, if it is considered like this, now you see once again, thumb is representing the rotation of the conductor, forefinger associate the direction of the mechanical force experienced by the conductor, whereas the middle finger will be inducing the, that is what indicating the back EMF which is induced in the motor conductor. So it is called as the generator principle, maybe AC or DC, or this is called the motor principle, maybe AC or DC. So like this, there are two, these will be discussed separately, whereas the Fleming's right hand rule and left hand rule, where they are utilized, that I had discussed.